Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
She has an MBA from Duke University and her PhD from the University of Utah. She's before returning to academia, she worked in IBM for 9 years in the Research Triangle Park. She's going to talk to us about some of her experiences with doing industrial case studies in extreme programming.
Hi. Well, thanks for having me here today. So what I'm going to talk about, as Nachi said, is 4 industrial case studies that we did with extreme programming teams. 2 of them were at Sabre Airline Solutions. Sabre Airlines develops products that support airline industries like reservations, baggage control, things like that. We did 2 studies with them. We did one with IBM in Research Triangle Park and one with Tekelec, which is a telecommunications company in the Triangle. Tekelec's claim to fame, they have 2 applications you might know of. One is they were the people that allowed us to, if you switch cell phone providers, you can keep the same phone number. That was a big breakthrough. Tekelec did that. They also broke the logjam. You know, there was one year with American Idol where if you tried to vote, it was always a busy signal. You hear that about that? And so they broke it so that last year all the voting went smoothly. So those are the public applications that Tekelec's done. So what I'm going to do today, first of all, is provide a brief overview of Extreme Programming 2. About a year ago, Kent Beck wrote the 2nd edition of the Extreme Programming Explained book and kind of redefined extreme programming. And so I'll give a brief overview of that, and then I'll talk about the empirical studies we did. And please interrupt me at any time. I hope to learn as much about Microsoft as you learned from me today. And so I would appreciate that. With Extreme Programming 2, one thing I'll say is that there was 5 years between the first book and the second book. And the first book, I think that Kent was mostly writing about his experiences and those around him with teams, not a lot of experience, though. And as 5 years went by, he saw he and others saw what teams really did and what really worked. And so the Extreme Programming 2 book is a little more, not as arrogant about what you had to do, and didn't say you have to do all things at one time. It was kind of much softer. And maybe because one of the authors of the book was Kent's wife, so maybe she put the female touch into the book. It's a little more realistic, I think. And so what he did in that book is break up the practices to primary practices and corollary practices. The primary practices, an arrow up at the top. What Kent says is the primary practices up at the top are just plain good practices. And you could take any one of them and institute it with your team and have good results. That they do work best when you put them together, but you can do any one of them. And then the corollary practices at the bottom are practices that once you have a core set of primary practices instituted, that you can start instituting some of them as well. I did notice, you may know I've done research in pair programming, and I did notice that Kent left pair programming off of the top of the chart. Trying not to be insulted about that. Okay, so yeah.
Was it on the bottom? I didn't see it.
Nope, it's missing. It's missing. So the one thing I'll say too, and I know that this is televised, so he could hear me say this, but in his acknowledgments for his book, he acknowledges 4 of his children. He has 5. So that was a worse mistake in the book than leaving pair programming off the diagram. Although he does say somewhere, he names the other daughter that he missed, but then when he said something about his children, he gives 4 names. So I thought that was kind of an oversight. So what I'm going to do is I'll talk about the primary practices of extreme programming, and I'll have a note like new, meaning that it was not in Extreme Programming 1, it is Extreme Programming 2, sustained, renamed. So I'll kind of have a comment to compare Extreme Programming 1 to Extreme Programming 2. Sit together is a new practice, and basically what it says, it's good for everyone to be sitting together in one room. And that's the sit-together practice. I mean, there's lots of research that go back many years that say this war room type of approach is a good thing. Whole team is a new practice. And again, this is something that goes back a long way. Basically, it's cross-functional team. So get everyone on the team, the testers, the developers, quality assurance, customer representative, get everyone together on one team. And he talks about tipping points. So 12 is the number of people that can comfortably interact in a day. And so that's a good team size, or maximum team size. And then 150 is a point at which you can't recognize everyone's face that's on your team. And so when you have teams of teams, it's good not to go above 150 people, is what he's saying. Informative workspace is another new practice. Basically just says, when you walk into a workspace where the team is working, you should be able to look on a wall and find out how the team is doing. What progress is made, what tests are passing, just so that you can get a good feel of what's going on. Energized work is another practice, which you like the graphics. The funny thing about the graphics is I was trying to get a picture of stereotypical geek. That's what I wanted, was geek. So I put geek into Google and looked at images and found those. And what Energized Work says, used to be called 40-hour work week, then it was renamed to Sustainable Pace, and now it's Energized Work. It basically says to work at only as many hours as you can be productive and only as many hours as you can sustain. So don't work too much. You guys don't work too much here, do you? No. Pair programming is a practice that was sustained, 2 people working together at one computer. And then stories is somewhat of a renamed partial practice, was in the planning game and called user stories. And the idea behind stories is to have customer visible functionality, short statements of customer visible functionality written on index cards as your requirements document. And the point of the story is that you know that you're going to have to talk to a customer to clarify the requirement. And so it's a commitment for further conversation between the customer and the developer. And so there's short statements of requirements, also put on there priority statements and how much resource it will take. And then you use those in a weekly cycle, used to be called the planning game, where the highest priority cards that can fit into a certain amount of time are prioritized for that weekly cycle. And there's a caveat. There's another practice called Slack, which comes into play here, which I'll talk about. Any questions so far? I'm trying to go through this kind of fast. Quarterly cycle is another practice, used to be called small releases. So basically says within a quarter you should be able to deliver functionality to a customer and be able to get feedback from a customer on that. And that you need to be delivering business value in that quarter. And then, yeah.
So is the quarterly the smallest?
The quarterly is the smallest. Well, you'll see when we get to the corollary practices, he actually talks about daily deployment. So I would say quarterly is the largest.
But in terms of delivering value to customer or business, is he saying quarterly is the smallest chunk of time you spend?
I would say largest chunk of time. So you should deliver value to your customer at least every quarter.
Okay.
One of the corollary practices is daily deployment, and that would only work if you had something like a web application where you could deploy new functionality into the web application. So Slack is a new practice. Slack says in every weekly cycle, plan some low priority tasks. So that if you have to drop something out, that you drop a low priority task out and the customer isn't upset because you're not missing an important commitment for the customer. And then another new practice is 10-minute build. So you should be able to automatically build and test your whole system in 10 minutes.
We've got 40 million lines of code that takes 15 hours to build and run. Is it true or what?
Well, every time I've shown this slide and talked to anyone in industry, they always say there's just no way. And so, I would say on one hand it's idealistic to think you can do that. On the other hand, it probably challenges you to think, what can we do during the day so that we can get feedback as often as possible. But 10 minutes is a very short period of time. Continuous integration is another sustained practice. Basically says you have these small tasks. When you finish your small task and your test case runs for that small task, that you put it into the code base. Run all of the tests over the whole code base and then put it into the code base. And I remember having an enlightening discussion last time I gave a talk here about 3 years ago. Because of the Microsoft Secrets book, I had the impression that you guys did daily builds and had new functionality every night. And at that point, I was informed that you have a daily build, but you don't put new functionality into that daily build, right? That's what I was told at that time. That we only put new functionality in every few months. Is that? No? You do put new functionality in? Good. And then test-first programming is another sustained practice, which has really 2 levels. First is the acceptance test level, that every feature has an acceptance test in it, and that feature is considered to be finished when the acceptance test case passes. And then there's another level of cycle, which is a unit test cycle, that you're writing unit tests and passing them continuously throughout the development on a minute-by-minute basis. Incremental design is kind of a renamed practice. I would say used to be called simple design and refactoring together. And so what it says is no big design up front. It's knowledge-based design so that you have your most effective design when you have experience, like the previous day's development experience will help you with your design for today. Still, the philosophies of do the simplest thing that could possibly work. Kent emphasizes that can possibly work in this book because he said, I get the impression he's gotten a lot of flack about that. And, how could we do this? How could we not consider security? And how can we not do this? And, so he's saying, well, that could not possibly work then. You need to consider everything that you need to consider in your implementation. Refactoring is an important aspect of the incremental design so that when you have code that's working, then you relook at the design of the implementation and improve it. And it's very important that you have unit tests to protect you when you do that redesign. And we'll see as we look at the empirical studies, the bank of unit tests really impact the refactoring practice. If you don't have a lot of unit tests, it's very difficult to refactor. So that's a summary of the XP2 primary practices and a comparison chart. And so if you look at the XP2 primary practices, there are 5 new practices, several renamed practices, and several sustained practices. And there were 4 practices that were in the first version of extreme programming that are no longer there. And my interpretation is that Kent saw that these practices teams didn't do, and they succeeded. So maybe they weren't as necessary as he thought. And I'll talk about some of them. One of them, the metaphor practice. And all of the studies we've done, no one has ever really used the metaphor practice. The metaphor practice said that you should think of some kind of an analogy for your team, your project, and name things according to the analogy. And teams just really didn't do that. And that's just removed. Collective code ownership was moved to a corollary practice, and I'll quickly go through those, and renamed to shared code. On-site customer, which I would have thought would have been a primary practice. But as we did studies, in many cases, people didn't have on-site customers, and they were successful. That got moved to a corollary practice called real customer involvement, and coding standard was removed. Okay? Any questions or reactions to those?
Yeah, why was coding standard removed?
Excuse me?
Why was coding standard removed?
He never explained why. It was absent. So he didn't explain why anything was removed. He just said, this is what it is. And I don't know if maybe he thought that was so basic everyone does it, and he didn't have to say it. And I'm not sure. Any other questions? Okay. So now we'll go quickly through the corollary practices. First of all, real customer involvement was called on-site customer. And what that said was that a customer needed to be available to answer questions, to clarify requirements. And like I said, with the studies we've done, in most cases, they didn't have that. And a lot of papers that I've read, that's a very difficult thing to do, to get a customer to actually be on site.
But how valuable is it in your research?
How valuable? So I guess, so it would help, but I can't really quantify how valuable it would be. So, and in all of our cases, and I'll talk through them, there was never an on-site customer.
Okay.
And they were successful. And that's my opinion of why it got moved, because it works. Email and other things seem to work. But there have been other papers that talk about how good it is, not quantifying it, and talking about how time-consuming it is and what a difficult job it is. So I think it could be valuable, but it can be a little impractical as well. Yeah?
So one question I have in this area, one thing that our team is struggling with, is that if you do not have an on-site customer, how do you document the process, and what sort of documents do you have floating around, or what sort of documents do you not have floating around to keep the customer in sync, and to have the customer sign off on what it is that you're building?
Right.
Because if they're on-site, you can just kind of chat with them, being like, hey, how is this, how is that? But if they're not, there needs to be, potentially, or does there need to be some sort of formal process of formalizing those requirements? Right.
And so, I'll speak from our case studies, and we've done other case studies in these 4, just not to the level of detail, is that there is always a responsive customer ready to talk on the phone, ready to Insta-message, ready to answer an email. And so the same type of thing happens. It just doesn't happen with them physically in the room. And that's in all cases.
With the customer close at hand, does it cause scope creep, the changing of how things are behaving, and cause the scope to change?
I don't think so, and I think because there's that weekly outlook, and so then if the customer wants something to change, then they have to pull something off, and so they need to make that trade-off, and because of that explicit trade-off, I think things stay in line.
They sign off that they're willing to accept the change, right?
Yeah, and it's not even sign off; it's more informal than that. But they can watch which user stories are in the iteration, and if they want to bring something in, then they have to take something out, to be fair.
They're paying for it, right?
Yeah. Okay, another one, incremental deployment is a new practice, and so this says to get your customers to actually deploy your software more often, rather than have this big bang, whole new financial system on Monday kind of thing, to have specific bits of functionality so that they can be replacing their other application. Team continuity is a new practice, and it basically says if you have a team that works well together, keep them together. And what goes along with that is shrinking team, that says as the team gets better because they've worked together longer and they have more experience, then don't add to the team, shrink the team, just say, okay, we have the same capacity, but so-and-so is leaving, and now we're going to have a smaller team.
Have you actually seen that used?
No, I have not. Root cause analysis is a new corollary practice, and I'm not sure how much you do root cause analysis here. What do you do here? Do you do much of that? Not much. So root cause analysis says, we had a defect. What caused that defect? How did that defect escape? And so the way that he's advocating doing root cause analysis is you have a defect reported by a customer or system test or something, and the first thing you do is you write an acceptance test case that will fail because of that defect, and then you write a unit test or multiple unit tests that will fail because of that defect, and then you get your unit test to pass, and then you get your acceptance test to pass, and so you see what caused the problem, and what you had to do to fix it. And then you analyze, how did that happen? What kind of test didn't we write? How did that escape to the field? So I think it's a good practice. Shared code is now in a corollary practice that says, yeah, go ahead.
Sorry, a question on root cause analysis. Is there some sort of feedback that says, okay, now you put this in the best practices? Or how does that learning go back to the team to improve the team?
Well, remember, the teams are small. And so all of this happens within the same room, ideally. And so you can, actually, I've seen root cause analysis done more in big companies like IBM, where there would be a root cause analysis meeting. And so the team would actually study things. I've never seen it done in programming team, because this is a new practice. So I don't know how formal it is, or if it's just personal learning. You know, you see this process yourself, and then you know what to do better next time. So shared code says that anyone on the team can change anyone else's code. And that's a corollary practice now, and it has some strong prerequisites. Pair programming being one of them, so that when you're changing someone else's code, at least two of you think you should make that change. Continuous integration, meaning you put that change into the build, make sure it doesn't break anything. And test-first programming, so you have a lot of tests, unit tests, that will tell you if that change was good or bad.
In a team of teams situation, is he asking for the boundary of that kind of shared code ownership to be within the team, but not across teams and teams?
Right. Did you hear her question? So the shared code being within the team, not within the team of teams. And then code and test is a new practice, which just says the only thing that you should archive are code and tests. No documentation, and then you should rely on social mechanisms to keep alive the rest of the history of the project. That any other documentation becomes obsolete, and so you need executable documentation.
So what about design documents, those stuff on the sticky and index card? I mean, they don't transfer to electronic media, they just stay on the
Really big box.
really big box. So if you want.
So no business requirement document?
No business requirement document.
No customer data?
Customer data meaning?
Information about your customer, what he does, what he needs, problems he has, personas.
I would say no. I mean, although some things like personas and those seem like business-related things, where this is actually implementation code kind of things. So
This isn't saying the whole life cycle is all you keep. It's just saying more for the developer.
Right.
Okay, good.
Right. But it would mean no design documents and things like that.
Like API documentation, one-on-one, all your code, stuff like that. That's deliverable maybe? Or?
So API documentation, so he'd probably say to put it in Java doc and things like that.
And bugs? Bug database? No?
I would say yeah to bug database. Like this is focused on the product. Yeah.
My read of that practice was that it didn't say don't document things. It said don't bother spending energy maintaining those documents. Do as much design on paper as you need to solve the problem, but there's no sense in trying to keep that up to date as the code evolves and changes. It's just a tool to solve the immediate problem.
That makes better sense.
Yeah, and thank you for that clarification, because I did intend, because it's permanent artifacts is the key. And so you do what you need to do, and actually even, and I'll get to you in 1 second, even if your customer says the design document is important to me, and that becomes a high priority item, and it would be in the iteration. But it's not an advisable thing to do. This is what he advises. But it was always like do the simplest documentation that could possibly work, as well as everything else.
So a lot of times, in regards to the code and tests, so working without a BRD, I've found projects where we've taken the BRD and we're able to translate all the things in there into the test cases.
And a BRD
We haven't spent a lot of time on business requirements.
Okay.
And we haven't spent a lot of time to go back and update the business requirements, but because all the needed rules are in the test cases, then that sort of serves as a business requirements document as well. So if the test cases really are all encompassing, then it helps to cut down some of the documentation.
Right, right. I don't know if I'll try to translate what he said if you didn't hear it. But if you start out, and this is, would be the way to go and not violate anything here. If you start out with a business requirements document and you translate that into the code, into tests, preferably automated tests, and then you don't have to throw the business requirements document away. It can serve whatever purpose it serves, but then you have these executable acceptance test case kind of things that would really document the requirements. And you would know if they were obsolete because you would run them and it would fail. And so that's a way to keep it up to date.
So this bullet seems to be really very much tied to the previous one that said keep your team together forever, right? Because this says rely on institutional memory, not paper, and the only way that's achievable is if you never lose anybody. Right?
Well, so
you get a lot of team flux, it's all gone, right?
Saying the code is more important than all of it.
yeah. So one thing I'll say, so yes and no. So these corollary practices do say you are doing the primary practices. Then you can start these. So yes for that. Keep them together forever is probably a stretch. And it is that the code and the tests are the executable documentation. And so where a paper document can become obsolete, something that executes, it's up to date. And so a test case, an executable test case, is as effective a requirement as a requirements document. And that can be kept up to date and can live with the. And I won't say that I'm relaying information. I'm not saying I agree with all the information.
So, question about functional specs. I mean, to me, that's always like the English way of understanding what the product does, and something that a lot of people in the team can understand and share. What does he say about that? Does that really go away? And if so, how does somebody like a PM understand what that feature is really doing without going and what's being built? How do you agree on the common definition of what's being built and tested if you don't have a functional spec?
Yeah, so functional specs definitely do go away, except that you do whatever you have to do. And so you can draw up whatever you want, de-emphasizing having it be pretty and nice and archivable. So whatever you need to do in order for your team to work together, whether it be a whiteboard that never gets erased or anything in between, to get the job done.
The idea being just to reduce the effort of maintaining the function.
Mm-hmm.
So I'm really interested in your research and less about debating XP practices because we're spending too much time on this.
Okay.
It's your talk. I know you're not here to tell us about XP. You're
okay.
here to tell us about your research.
Okay. So there was one more hand, though, before I go. So, yeah.
So one thing that I guess is captured in documents that would these corollary practices go away is the reasons behind some of the features. Because as you said, like the actual functionality of the code will be maintained in the code and in the tests themselves. But the reasons why something was developed the way it was developed is not. Is that okay to lose that information? Especially as you go forward and decide to change a feature, and you're like, why do we do it this way? Let's just do it this way without thinking of all the reasons why that was implemented in a particular way.
And I think that would be one of the things that rely on social mechanisms. Okay. And as much as it's, debating practices, you'll see some of this reoccur when I talk about the empirical studies as well. So these are three that are, probably a little more far-fetched and would be dependent on your type of application. So daily deployment says put new code into production every night. And like I said, the only way I can see something like that happening is if you have a web application and you can put new functionality out there. You certainly can't do it to regular customers. Negotiated scope contract, you have fixed time, cost, and quality, but call for ongoing negotiation of scope. And pay-per-use, charge for every time the system's used. So it's kind of like every time you make a phone call, that software is used. His reasoning behind this was that you'll be able to tell if your software is high quality or not by how much it's used. But again, you can't do that in many, many cases. So, okay, so those are the practices. And so now I'll go on to the studies that we did. And so all of the studies were structured based on what we call the Extreme Programming Evaluation Framework. And what we wanted to do before we developed the evaluation framework, we read lots and lots of papers. I'll just call them success stories of teams. You probably have read them too. That would appear in the literature, and it didn't have a real structure to it. And they weren't never measuring the same thing. And so from a researcher standpoint, you can't develop a body of evidence if every time someone does a study, they measure something else. And so we have a framework that has three main categories. First is context factors that says, what's the size of the team, the language, lines of code, just basic demographic kind of information that would help you as a consumer of the information to know, is this team like my team? Is there any similarity between this team and my team? From a researcher standpoint, we can find the limits. We could build up a body of evidence and understand, well, this works for small co-located teams, but as soon as you have them geographically distributed, things break apart. We can see what the differences are. And we can see that by watching the context factors. Then we have XP adherence metrics, and so that basically says, did the team do extreme programming? And so it goes through the practices and tries to assess whether or not they did it. And you'll hear, I've had lots of conversations with teams that say, we tried extreme programming and it failed. And when it really got down to it, they didn't do test-first programming, they didn't do pair programming, all they just did, they didn't do design. That's all. It's the only, and I mean, I can't tell you how many people I talked to where that was the case, where I would say, did you do this? No. No. But you know what? We really wish we had that design document when it all. It's like, well, of course, because you didn't do any of the others. And so what we wanted to capture is what is the team doing, both from seeing whether they did extreme programming at all, and also watching for trends between which practices seem to be essential and which don't. So that's the adherence metrics. And then the outcome measures are your basic business-related results, like productivity, quality, things like that, that a business person would care about. So it manages, what's the result of this adoption. Just as a side note, we also have evaluation frameworks for the team software process and the rational unified process. And from a presentation one of my PhD students did last week, I think you guys are doing a lot of team software process, is that right? There's a whole bunch of people from Microsoft at the SEI.
It's a very big company.
Very big company.
It's a corporate standard for IT department.
TSP is? Corporate standard? Okay. So the first team that we worked with was an IBM team in Research Triangle Park. And the first two case studies I'll talk about are what I'll say are small co-located teams. And that's kind of in the context of what should an extreme programming, like the original literature said 10 to 12, no more than 10 to 12 co-located object-oriented programmers. And the first two case studies fit right into that. This IBM team was an island of extreme programming in the middle of an IBM culture. And so they did not have management saying you should do extreme programming. They had a champion in the department who said, I want to do extreme programming, and was influential enough with his teammates to convince them to do extreme programming. And worked together as a team, to get their own training, and they just had the kind of culture that's the kind of thing that the team wanted to do, and he was able to do that. This champion also had to do some work to fit into the minimum set of interfaces. So he might take the user stories and type them into a document to call them requirements. He took it upon himself to do that. So he just did all of the things he had to do in order to not ruffle any feathers within IBM. So small co-located team. They did web development. They took some code from an IBM team, worked on it, and then sent it on to another IBM team. All three of those teams being in different geographical locations. And because of that, that's why he especially had to document requirements and some interfaces and things like that, because that was expected along the way. And what we did was we examined an old release to a new release. The team had already begun to do some extreme programming-like things because they didn't like heavy process. So they weren't starting from ground zero. And you'll see this chart on a lot of the teams. This is a polar chart developed by Barry Bain at University of Southern California. And the point of his polar chart is that if you look at the factors on the chart, which I'll go through, if the team's factors are far from the middle of the polar chart, then that says that's a plan-driven. So it's agile or plan-driven. And so if the point is above, far away from the center, then that's a plan-driven type of factor, where if it's close to the center, then that would say this is a good thing for Agile. And so the 5 things he talks about, first of all, personnel up at the top. That says, what's the skill level of the team? And it's not, you could be a person who has worked as a programmer for a really long time and not have a high skill level when you go into a new department because you're learning new domain. And so a highly skilled person would be able to be technically sound and also be able to change procedures because they were comfortable enough in order to do that. And so if you're highly skilled, you would be towards the center. If the team had less skilled people, it would be towards the outside, meaning those people are more likely to need the documents that aren't produced in extreme programming. The next is dynamism, so percentage of requirements change. If it's outside, that says these requirements are really stable. Inside says these requirements change a lot. The reasoning being, if your requirements are really stable and are never going to change, why not just have a requirements document and go through it? Why do we need all this customer interaction? We know exactly what they want. The next one is culture, so the percentage of people in the team that thrive on chaos versus order. So if you thrive on chaos, extreme programming is good, and you go towards the middle. If you thrive on order, you go towards the outside. Size of team, so Agile is good for small teams, maybe not for large teams. And criticality, so if you have a defect in the code, what is the impact? Loss of comfort, so if it's a game, some kid gets mad, would be towards the middle. And outside, many lives could be lost. And so if you look at the product and the team, you graph these factors. And so looking at this IBM team, the factor that's most plan-driven is the criticality, because an organization could lose critical funds if there's a defect. But for the most part, that looks, the shape is fairly towards the center, and it looks like an Agile methodology is probably fine for this team. Yeah?
How did you measure the culture one?
The culture one is based on, I'll talk about this Shodan survey, which is, so it's a subjective measure based on a survey, is what I'll say. And the context factors in the evaluation framework are many more than this, so this is just a high-level overview. And so the adherence metrics, and this is the Shodan survey. So we have one thing, and this was developed by IBM, called the Shodan survey, and it basically asks the developers to go through the practices and say how much do you do them. And so it's very subjective. It is anonymous, so they're not, they don't have an incentive to say they do something that they don't do, but yet it's subjective. But if you look at the team, they had a score of 56%, and then as they instituted more of extreme programming, they went to 72%. It's really hard to say, we're 72% XP. It's really not a good measure, but the change does tell us something. And what we try to do is to take the subjective measures and add as many objective metrics as we possibly can. We can't do all of them because it's hard. Subjective metrics say the team can't interfere with this. We're going to measure something that they can't manipulate. And it's hard to do that with some of the practices, many of the practices actually, but we're working on it as much as we possibly can. The survey results for this IBM team, the things that were low for them, refactoring was low. And if we ask them why, it's because they didn't have the unit tests that they needed to have. Metaphor was really not used at all. And then some of the others that come out here, the first several objective metrics relate to testing. And this was a team that really wanted to try to get the testing instituted as much as possible, but we're dealing with a lot of legacy code, and that's a problem when you try to institute automated testing. And so if you look at some of the things we measure, it's like automated test class per user story. It was 11% of them had automated tests, went to 45%. Statement coverage went from 30 to 46%. Unit test runs per day actually went down, so that wasn't so great. The ratio of test lines of code to source lines of code went from 0.26 to 0.42. Someone in extreme programming would say that should be about a 1-to-1. You should basically have the same number of test lines of code to source lines of code. And so, they got better, but still have a ways to go. They still had manual acceptance test cases that the customer did not run. So, they made some progress in testing, but still had a ways to go. Pairing frequency went from 5% to 48%, and it jumped that much because they had a ruling basically that said if you don't pair, you have to have your code inspected. And so they had a trade-off there, and when they had that trade-off, the pair programming went up. Release length went down by about half, and they had weekly iterations. Any questions about that? Yeah.
Sorry to interrupt.
No, it's no problem.
So pair frequency, one thing I don't understand there is that the trade-off between having your code examined and comparing with someone, you're probably going to be less productive to compare with someone because essentially you have your productivity time as opposed to going over your code with someone later, which you can do probably in less amount of time. So would you say that pairing kind of slows down development as a result?
So I'll say as a whole, and research I've done and others as well, is pairing doesn't double the amount of time it takes. It actually can be almost, you finish almost in half the time. And so, you know, that was the research I did, but others have done as well. And some will even say that it's even faster than double. And doing it myself, I can see, you can feel. And I don't know if anyone here wants to say that they do it in their experiences. You're shaking your head.
Yeah, I work a lot faster.
Right. I mean, you just kind of like, you wonder, why did that happen? And the other person says, oh, that happened because of, it's just very fast.
It could be as simple as not taking 5 minutes to check my email.
Yeah.
Because there's someone sitting right next to me expecting me to work on the problem.
Right. Right. There's a lot of that. You know, you won't answer your phone. Someone will walk up and see, oh, they're working, and walk away. I mean, so there's a lot of reasons why your productivity can get better.
We often look at it as like a pilot and co-pilot situation. You're both concentrating on flying the plane, you're just doing different activities. So it's a team effort to make it work.
And it is really fast. I mean, when I've done it, I mean, it's really fast so that after a while you just have to stop. Because, you know, you get to a point where you just can't do it anymore. And then you go answer your phone and do your email and things like that.
The shared knowledge part of it is huge.
Right.
Component. Being able to trade information, the concept that you're supposed, in the project, you're supposed to gravitate to the concepts that you know the least so that you get more familiar with them so that you can better work on the project as a whole moving forward.
Mm-hmm. Yep. Yep. Thanks for that. And then the other trade-off is at IBM, it's not, and then you just show your code to someone else. It's actually a formal inspection. So it would involve 5 people, 4 people. So, any other questions? And so what happened to this team? First of all, they had 23% requirement change throughout the iteration. We measured 2 things. First of all is pre-release quality, so test defects per line of code. And they had half the test defects per line of code. And so that's kind of, I'll call it a surrogate measure, because that could say, well, we didn't test very much. You know, I mean, it's hard to say what that really measures. But actually, they had double the number of tests for the new release than the old release. They ran all the old releases tests as well as another whole set. And so they did test as much. Post-release quality is release defects per line of code. And that was for the first 9 months after release. And they had basically 60%. Productivity is very difficult to measure, so we offer 3 measures. One is stories per person month, lines of code per person month, and then something called the Putnam productivity parameter, which actually kind of tries to normalize for number of people on the team and elapsed time and lines of code. And if you look at all of those metrics, that, you know, all say that the team was more productive than they were before. But again, there's a caveat, because none of those are exact measures.
Lauren,
yeah.
Can I just validate, you're saying 0.61 defects per 1,000 lines of executable code?
Okay, thanks for asking that question. It's actually a normalized value. So IBM doesn't want you to know what their defect density is. And so there's 1.0s in all of the old, because that was the baseline. And so basically it's saying 61% of the old value. That make sense?
Okay. But they're not telling us what the old value
Right,
was.
right. They don't want you to know, and you don't want them to know.
You're talking about 2 releases of an ongoing project in here. So to which extent would the accumulated knowledge have resulted in these improvements anyway?
Yeah, it's hard to say. And so all in all, with industrial case studies, I mean, they are more compelling to people like you, because if I came in and talked about student studies and all these exact things, you wouldn't be so interested in it. But there are limitations, such as what's the learning that takes place, it's specific people in the team, you know, it's 6 specific people. And so all of these things are limitations of all case studies. Yeah?
Talk about customer sat. It says it was not available in the
high.
Yeah.
How are they measuring?
It's by survey. I mean, not by survey, by interview. So what we would do is actually talk to the customer of the product, which in this case was another IBM organization. And we have a survey in the evaluation framework. We have a template for the survey that we ask customers in interviews.
So in terms of time, were they highly satisfied because the releases were shorter or faster?
They were more.
Or was the quality?
Right.
Or
right. So quality and functionality is primarily.
Okay. Were they aware of this way of releasing the XP, or they had no clue?
No, they knew that the other team was doing XP. Okay. But as I said, the champion kind of buffered them as much as possible. So they knew there was a change, but they had minimum impact due to the change.
Laurie, how would you categorize their initial quality in the old? So without telling me the defects per line of code number, because this 40% reduction doesn't strike me as very impressive. No. So was this already a very good team?
Yeah. So the customer was already happy, and then they were even happier. So they had a respectable defect density.
Okay, because I've seen numbers like
98% improvement, 99%, 99 point something percent, going from truly lousy to really good. And there's documentation in the literature that says you'll get 5 or 6 defects per line of code, and you can drive that down to less than 3 per 10,000 lines of code. So that number of 40% isn't very impressive. So knowing what the 1.0 really represents is important.
Right. So one thing I'll say is percent improvement is not what I'm showing here. So if 98% improvement would be a 0.5 or 99%. So that would mean it would go down by half. So this is saying if it was 5, then I can't do that math in my head. It was 3.
So, but if it was 1 defect per 1,000
lines of code, it's now 0.61.
Right.
Right.
Right. But they definitely had respectable quality. It wasn't an issue before. And then morale was based on that Shodan survey again, and so Kent Beck will say teams are happier when they use pair programming. They improved on their morale score on that.
How many iterations of XP, like how many little releases do they go through between old and new? I mean, is this just the first time through they already had these improvements, or like after 5 cycles and kind of stabilized?
Right. So they had weekly iterations, and so this was one release to the next release, back to back, over 5 months.
Okay.
Right. And some of the others there are bigger breaks in between, but this was one release to the next release, but there was 5 months in between. Okay. Okay. Sabre has 2 case studies. One is called Sabre A because they were more characteristically agile. Sabre P is the next case study because they were more characteristically plan-driven. So one thing about Sabre is that the vice president of development said, we are doing extreme programming to his team, all 250 people. Doesn't matter what your product is, what the team size is, we're doing it. So that was very different than the IBM case. And so they had some where, like in IBM, XP says use OpenSpace. Well, they didn't have it. They didn't have support for facilities changes. They had that kind of support in Sabre, and they didn't have to fight any battles as far as making documents that they didn't need or anything like that. So if you look at the polar charts for the before and after, for the most part, all of their factors said this is good for an agile team. Culture was the one. The team was resistant. They wanted more order than extreme programming was going to allow. But the after, you can see that they got used to it. Some of the people changed as well as they were fine with what happened. You can see there's from mid-2002 to late 2003. So there are several releases in between in which they were getting used to extreme programming. So by the time they got to late 2003, they were quite used to extreme programming. And so some of the biggest changes, they had a waterfall process. They went to extreme programming. Still small team, 6 to 10 people. Not a lot of turnover. They were co-located. They had overseas customers. This is the case where they had an on-site customer marketing representative that was responsive to them, and they had a lot of email contact with their customers overseas. They had double the number of customers for the new release, which does have an impact on defect density when you have more people using the product. They went, Java and C++. They did have open labs. That was one thing that the vice president provided for them was open labs. A lot less person months, so they went from, I think it was 18 month to 3.5 month iteration or release times. So much less personnel months and much less similar lines of code.
Laurie, is there a correlation between
personnel turnover and the culture metric, is that because the people who didn't want to be agile just left the project? So during 2002 you had the 67% mass exodus and then you hired on the right people?
Well, for the most part, no. But I will say, you know, when we went to Sabre, there was not universally happiness about all of this. There were some people that did not think this was the way to go. But in this particular team, that was not the cause of the turnover. And then as far as adherence metrics, when they took the survey, and we didn't have an old survey, we only had the new team do the survey, 77%. And there's a lot of similarities between the teams. So they didn't do refactoring as much. If you look at their testing metrics are better than IBM's. I won't go through each one by one. But they were trying to do testing, running into legacy code problems, which impacted things like refactoring. Didn't do metaphor. So like if you looked at the IBM team and the Sabre team, extremely similar. They also went up to 50% pairing from basically none. And again, they had, you know, inspection versus, it's a common theme to have inspections versus pair programming. And then I said their release length went down, and they didn't have iterations before. So before they had one 18-month release, nothing in the middle. Now they had 10-day releases, 3.5, or 10-day iteration, 3.5-month release. So a lot more feedback along the way. And if you look at their metrics, they didn't keep track of their requirements changes, but again, you know, higher quality. And one of the things, so pre-release quality, they had much less defects, but you know that metric needs to be considered because you have to measure the test quality itself. The post-release quality went down, and you won't be impressed by it, but they had double the number of customers, and the defect density went down. So they had two things that happened there. Productivity.
It's very hard to read the number. You know, 30% could be massive if they're already quite good. But if their initial quality was industry standard lousy, which is 6 defects per function point.
6 defects per 1,000 lines of code, 100 lines of code.
Right.
Then a 30% improvement doesn't reflect the amount of testing and pairing and that kind of thing.
Right.
With fairly good test coverage and pairing, you'd expect to drive that down significantly. If you're starting at a very good level of quality, then obviously it's difficult.
Right. And so, and actually Nachi is my PhD student behind you, and he's worked with Sabre some. And one thing I'll say about Sabre, they do have very high quality. Their applications are airline reservation systems, baggage handling. I mean, so these are things that they can't tolerate, and so they always had high quality.
Is there any connection here to the Michael Feathers book, Testing Legacy Code? He writes about Sabre.
Oh, does he?
Yeah.
And what does he say? Because I'll show you the next case.
I think, I haven't read the book myself, but I believe he talks about agile methodologies that were used during the projects that he was involved with.
Right. And I don't know what he says. In the long run, does he say it worked or didn't work?
He's a proponent of it, so
yeah. I mean, I didn't read his book, and I'll say, when we talked to the team, they definitely surfaced that. The next case study, you'll see it in spades. And I also, the vice president of development that started this all, he did tell me, I guess it was a year ago at the Agile conference, that one, that even though he'd said all teams do it, he was starting to believe at that point, so this was summer of 2004, that teams with large legacy code bases may not be the best candidates. And so I don't know what Michael says, but that's what he's hearing from his team. And so one thing, I'm not incriminating Michael at all, but in general, a lot of the books written by the extreme programming advocates advocate that it'll work in all situations. Okay, customer satisfaction high, and again, this is anecdotal based on interviews. Morale, 68%. There's really no reference point. That's based on the survey, but we don't have a pre-number. So this is the Saber P, meaning that it would be primarily a plan-driven kind of product. And if you look at the polar chart, some things that you can see: the less skilled department, not very much requirements change. Team thrives on order. Larger team, 15 is not that big, but it is larger than the others. And in this application, you would only lose discretionary funds. So that was the factor that was mostly Agile. But the rest of them would say that this team might have some struggles with extreme programming based on those factors. This was the 13th release of the product, and it was after 20 months of using extreme programming. And it was a large web application with a 1 million line of code base. And their customers were domestic and overseas. So if you look at what they did, and you can basically look at those testing metrics and see that they had a lot of trouble testing. So their automated test class per new change class was 0.0225, test coverage 7.7%, and this is over the code base. It's not over just the new code. It would be too hard to identify that. Unit test runs per day, so they ran every 2 days. And then the ratio of test lines of code to source lines of code still quite low. So the team tried to do it, but they just couldn't do it. They did have 70% pairing, release length of 3 months, and iteration 10 days. And so one thing I'll say is there's not an old and new release. We didn't have any historical data on this team, so we just studied what they were doing. And what we did was compare them to industry standards. And so we only had a few that we could look at industry standard-wise. Pre-release defect density, our standards were the Bangalore Spin Benchmarking Group and Capers-Jones. And so based on those benchmarks, they had similar pre-release defect density or lower, depending on the standard. And then total defect density, which is pre-release plus post-release. And this was in the first 4 months after release. And their defect density was lower than industry standards in both. Productivity similar or higher to industry standards.
Do you have reason to believe that the test coverage matched the equivalent for the industry standard? Because clearly the coverage and the number that comes out is a defect density support.
Yeah. I can't say. I mean, so their test coverage was low, as you saw, but what I see in many cases just in any team is that test coverage is really low or non-existent. Lots of teams don't test very well. And then the last case study is Tekelec. The Tekelec case study was interesting in that it was a geographically distributed team. And so there was consultants or contractors in the Czech Republic working with the Tekelec team in Raleigh. And they developed a simulator for telecommunication signal transfer point in which they train new customers. And this one, because it is a simulator, they didn't care about us releasing defect information. So you'll see what it is for this team, because it's not their product. It's just a simulator. They had considerable amount of requirements for volatility. So this team really tried to embrace the spirit of extreme programming, even though they were geographically distributed. So if you look at and it was a brand new product. It was a new simulator, so they had a better chance than other groups. And so they had an automated test class for every new or changed class. They didn't tell us their test coverage. They ran the entire suite of unit tests every day, and then they had what they called a quick set, which was a small subset of tests that they ran once an hour. Their ratio of test lines of code to source lines of code was 0.91, pair programming 77%. 4-month release and 10-day iteration. And so they really did try to do extreme programming as much as possible. And this was a new product. We had nothing to compare it against. They didn't tell us their pre-release quality measures. They did tell us their post-release quality measures, which was 1.62 defects per lines of code, which is lower than industry standards. Customer satisfaction in various areas. So capability, the customer was fine with it, not overwhelmed. Reliability, they were satisfied, and the communication with the team, they were very satisfied with. Productivity, if you put the test code in there, was lower than industry standards. Or if you don't put the test code in there, which was basically doubling the lines of code that they wrote, they were lower. When you put the test code in, they were higher. But you shouldn't put the test code in. So their productivity was lower than industry standards.
That's saying 1.22 thousand lines of executable code per programmer month.
Mm-hmm. Right. But some things that came out, so they did extreme programming as much as they did, but you need to know about some other things that the team did to manage this distance. And so when we did this research, we came up with some conjectures of what does it take to make this successful with a distributed team. And so one of the conjectures is that you need a well-defined customer authority, which is part of extreme programming. And it's kind of obvious, but the first month that the team worked, the customer representative was waffling around and not making commitments, and the team struggled. And then just simply by replacing that person, then the team got back on track. So it's very important. Another thing that the team did was they had the development manager, who was from the Czech Republic, sitting in Raleigh. And then the rest of the team was in the Czech Republic. And that turned out to be something major, so that there was no language barrier and there was no culture barrier. And so they bridged the gap for that team. They had prompt responses to asynchronous queries, meaning that every day when the Czech Republic would email questions about requirements or anything else, that they knew that they were going to have an answer when they woke up the next morning. And so they could rely on having those answers. And that was very important to the team. Also having access to process and product information. So they used the X-Planner tool, which was online. Anyone in the team could look at what was done, what the requirements were, how people were doing. So on both the development manager's part, the team's part, everybody could see everything that was going on at all times, and that was very important for the team. And so to summarize, if you look at the various aspects that we look at in research, pre-release quality, when you look across, generally looks like pre-release quality does improve. Post-release quality across the board improved. Programmer productivity, is kind of mixed, where 2 case studies would say that productivity did improve. 3, the third one similar or higher, and then the last one looks like did not improve. However, that was a distributed team, and so we don't have a standard for distributed teams. Customer satisfaction looks, yes to neutral to very satisfied, and team morale, not many data points, but the team was happy. So this is a summary, and then I have a slide which has all the papers if you wanted to go and read the papers about these case studies. So I can open it up for general questions now. So do you guys do any of these practices? Anyone do extreme programming? So what do you do? The whole thing or some?
Some.
Some. And which are some of the sums?
We're not doing metaphor.
We do refactor. We do continuous build. We do test first design, development, common ownership. Most of the engineering practices are embraced. Most of the project management ones are not.
We actually just implemented a Visual Studio 2005 application. We used a technology called Click Once, which allowed us to basically build our environment, roll it out, and distribute it to all our users within less than 10 minutes, just a few minutes actually.
Wow!
So we built this whole application in the last month, and we did it in small order of fashion like that. Start with the business requirements document, and we turned that into test cases so that we'd have for every requirement a test that had to pass or fail. And then we had the team work together in pairs, sometimes singly, but also in pairs, so that we could, and that helped us a lot to spot defects. One person could easily see what the other person was missing. And then everyone had access to all of the code, so everyone could see each other's changes. So we published everything back in and then got the latest versions everyone was always able to build and see. And because of that, we were able to quickly build a whole bunch of versions of this, get customer feedback constantly, because we had our customers on site with us a lot. And it really helped a lot to work in this fashion. I don't think we could have achieve what we did in such a short period of time without using these methodologies.
Great. Good. Yeah.
So this is a question mostly for the audience of folks who have done extreme programming at Microsoft. So Microsoft is very kind of rigid framework of types of people they have, the developers, then the PMs, and then the testers. A lot of what extreme programming does, as far as I understand it, is kind of blend those roles somewhat and kind of invent new roles. So how does that fit into kind of having these classes of people that work on a project and how they fit into extreme programming?
I can answer that for my team. I'm in Visual Studio. All our PMs can code. All our testers can code. We often share the
the burden of writing the code, fixing bugs among everybody. We're really blurring the distinction between those three silos. Commitments from our upper management people. So it can work here. And in fact, this answers your question too. You're not looking at me, but it addresses your point too. We don't write functional specs too much because all our PMs can code. They can at least read the text.
Any other comments?
I'm curious what this does, what these methodologies do for indoctrination of new people into the team. My team has done some interviews and some research into how people program at Microsoft, and there's a tremendous variation in uptake of Agile methodologies. But one of the things that seems so difficult about kind of the separate offices, and you work on your bug, I work on mine, is that new people, the ramp up for new people is awkward. And it seems like this might fix that. Is that something you've seen?
Yeah, definitely. So the question was really, does this help new people? And absolutely, it helps new people. If you come in and you pair with a different person every day and everyone's co-located in the same room, new people, it really helps. On the flip side, some people who would consider themselves experts say, I don't want to deal with that. And I would say that if someone is an expert and doesn't want to work with new people, then they shouldn't be forced to do it, because it won't be good for either side. Any other questions? Yeah.
Wait. Paper, Arlo Belchi's paper, promiscuous pairing for the programmer's mind. That seemed to be the
beginner's mind.
What's that?
Beginner's mind.
In the beginner's mind. And that seemed to be the most quantitative study. It looks like about how new people can be helped. It looks like it had a huge impact at the Denver conference. So that being said, does that spark up any interest with you or with anyone else that you know in the university that might be interested in furthering the study along those lines? Because it basically is only one case study, right? The company's out of business now. I don't know how fair it is to say that, but apparently the software production part was successful, just the business end was not. But it'd be interesting to see more quantitative stuff about that.
Yeah, and I'll say that I've not been successful even over 5 years getting companies to let me study pair programming. They let me study the whole thing, but not one particular practice. And so replicating studies is a good thing, especially if you make the context more generalizable and the numbers. And so if I had a volunteer, I would do it. Do you want to volunteer?
So where are you going next? You've got some proof that doing lots of testing improves quality, doing short iterations improves quality and productivity. And we could have predicted that. So what's next? So you've validated that. That's great. What are you going to do next?
Right. And so I would say that I'm interested in looking where are the boundaries. So what I see in companies is, like you're saying, everyone's saying, okay, short iterations are good. We should do that. Obviously, unit tests are good. And so a lot of the practices are just being done now, and that's great. And maybe extreme programming will fade away, and some of the good practices will be practices that everybody uses. But what I'm interested in, and that's one of the reasons we got to RUP and we got to TSP, and we could do a Microsoft process as well, is looking at what is the makeup of a process and what's the best process for the right team. If you have the parameters of a team in a project, what's the right process, and what are the lines around that, and maybe it's interchangeable based on culture. So maybe a team software process or extreme programming would both work for a certain team, and then it's the personality of the team that could choose.
Consider studying what's the right iteration length for a team or project situation.
Because at the moment, the industry seems to be in a I brand myself by my iteration length. So Ken Schwaber's a 4-week iteration guy, and Craig Larman's 3 weeks, and Kent Beck was 2 weeks, but he went to 1 week, occasionally 1 day, and Ron Jeffries is still kind of a 2-week guy. To me, that's just patently wrong. One iteration length does not fit all situations.
Yeah, I agree with that. And so it would be hard to study it in that respect. I just think that whether it be 1 week, 2 weeks, 4 weeks, it's at least short. You know, because say 5 years ago, people were at 3 months, 6 months, a year.
The RAD movement was like 3 months.
Right, right. And I know that even, you know, one of the first groups I talked about was in Vienna, Austria, and this one guy was telling me that now he knows when I get in the morning, I need to do this because I know what I need to have by Monday. Where when he had a 3-month release, he walked in and was like, what should I do today? You know, and didn't really have a clear cut. You know, and then that makes you work a lot of overtime at the end because you don't, you know, you build yourself up so that you didn't do enough early on. So I don't know, you know, 1 week, 2 week versus 4 weeks, you know, what the impact of that would be.
Is it worth studying?
I don't know. Do you think so? You're the customer of our research. Do you think it is?
I think it is.
You think it is?
I think batch size is one of the most important problems, and how big a batch of development are you going to try and do. And I also think that it would help us get beyond this I brand myself by my iteration length recommendation. Because Microsoft has a whole different set of problems from a lot of the places that you see the Agile movement guys working in. You know, so you come in with data that says team sizes of 7, 8, 15 people, and then you talk to executives who say, well, I've got 2,000 people in my group, and currently our product cycle is 3 years. And that's a medium-sized problem for Microsoft. There's another set of executives with an even bigger problem than that. So it's very difficult to get them to recognize that this stuff could be positive. So figuring out how you scale it across different domains and different problem sets is, I think, really important thing that we could do next.
Yep. And I'd be happy to work with you on that.
I was hoping to see more real data on improvements in customer satisfaction. Unfortunately, the starting was usually NA.
Yeah, but it
so
was.
If in your future studies, if you could focus more on real crisp there, that'd be great.
Okay. Any other questions? Yeah.
I'd kind of like to see more about people who have heavy methodologies that they're currently using, you know, with a lot of process and a lot of overhead, and what happens as they shift more towards the Agile side of the spectrum. Like, I don't really care if you're saying XP or Scrum or what have you. I just want to know, we used to be much more process-driven, you know, and now we're trying to get more Agile, because that's one of the things that I'm constantly trying to advocate in the IT group here at Microsoft, which functions very differently than the product business. So in my own case, I'd like to know a little bit more about how that transferred.
Okay. And so Sabre, it was completely that. So they had 250 people, high process, went to Agile. And so within that, what are you interested in? Culture or?
Well, there's a lot of questions. One of them is adaptation. How do you get the team to change their mindset from what everybody knows is a waterfall, right? And this is the way it's always been, the way we've done things, to now we're doing something very different. We're a lot out of our comfort zone, you know, and we've got eyes watching us and all that. So how to kind of manage the transition. So that's, and of course, it's just the sort of, do you take a dip in productivity and then come way up, or those kinds of questions that I.
Right. And so this is within, so Sabre was maybe different because their vice president said you will do it, where yours is more of a, like IBM, where you would like it and maybe some other people would like it, but they're not being addicted.
It's more evangelizing and trying to get a mind share to embrace new ideas and have an exchange of ideas.
Kevin's hinting at something that might be important. You might already have the data. The whole J-curve effect, the Virginia Satir change model thing, of things get worse before they get better. If you wanted to build trust in an executive that, okay, we're 3 weeks into this and things have got worse, but trust us, it will get better,
it'd be nice to have the reference data. So rather than just show at point A we were here and at point B we were here, what happened in between? Did it go down, and for how long, and how quickly did it come back up? If you have that data already, that would be worth publishing.
I don't. I mean, the only reference point I have more is anecdotal, and only on a different case study that was just test-driven development, where there was a 4-month project, and the team did say it slowed us down because it's hard to learn how to test. And it did slow us down, but by the end of the 4 months, they didn't exceed their resource estimates or anything. So they made up for it within 4 months, going down and then coming up. But that's the only reference I have. But I'll look out for that. Anything else? Okay, thank you.